Hey guys, Brian here. Welcome back to the shop. Got a couple hours here today to fool around on this mill, and I think I've got most of this hump pulled out of it. I'm pretty satisfied with how it's running now as far as the alignment on that goes. So let me give you a look at that. We'll see how I've improved it as far as the twist and the running of the ways. And then I'm gonna get my granite cube and put on here, and we'll start tramming in the column. But let's fire this up and check these ways first. Alright, I'm in as far as it'll come, so I'm gonna start feeding you out. Just about all the way out. I get you zoomed out just to prove to you that it's moving. Now let's get it turned 90. Well, I have to look and see exactly how this recorded on the camera, but it looks pretty good to me. So, on to doing the column. I'm gonna get the table cleaned off, I'm gonna get the granite block over here, and we'll check it out. Hey guys, Brian here. Welcome back to the shop. We're continuing on with mill evaluations, and what I've got here is my Devil tense indicator and the mill spindle. This is well beyond what's needed for this application, but I just want to see just, you know, how good it is. I know how good my other mill is, and this one's way better. I can already tell you just from what I've fooled around with it. I haven't played with the 10th indicator yet, but it was good enough playing with the 1000th indicator that I decided I would fish it out. I'll show you what I got going on here. So what I have is a 10th indicator mounted on the spindle, and I've got my granite square cube, I guess. It's supposed to be finished all 6 sides on this particular piece. It's also got holes in it you can sweep and indicate, so we might get into that as well in this inspection process. But for now, I've just got this laid on the table. So this is showing how it relates to this table. Anything that's high spots or low spots on this table will show up in this plate being tilted. So what I'm looking for as this moves isn't necessarily that it stays 0, but that the trend is continuous, because that would just indicate that the plate is not sitting flat on the table. You know, if it rises up all in one direction, it could just be that this plate is high on one end on this table. It doesn't indicate that the axis is out. However, if it does stay close to 0, then that's a good sign, because that means that the table is fairly flat and it is running in the correct motion in relationship to the headstock. And it still doesn't verify that this head is pointed the correct direction, because we're not checking the spindle orientation, because we're just going to move the table. So if this is drooped down, this is not measured in this particular measuring scenario. So we're going to measure out, and we're going to measure across, and we're going to see how these axes look, and hopefully it looks good. Let me get the measurements on this plate. I will say the other day when I checked this, it was in the 50s in here. Today it's in the 30s, and when I did the leveling on the mill, it was in the 70s. So we've been all over the place temperature-wise. We'll see how much it affects it, if anything. Not that we can tell necessarily, because we don't have the values of what it was then, but the level was pretty close then, so we'll see if that translates into this. "18 wide and 24 long." So we're about, we're over the width, we're twice the width of a Bridgeport table and about half of the travel. Well, I don't have that much travel. The table's that long. It's about half of a table, but the travel's probably closer to 2/3 maybe. Like they travel 36 maybe. Anyway, let's fire the mill up and check it out. Should be able to see the movement of the 10th indicator there. This may jump a whole bunch, and when I start moving it, and I may have to re-zero it, because the indicators, when they drag one way or the other, tend to always go goofy most of the time. But I'm in as far as I can go right now, so this is like the worst section of the millways. I'm confident that as it goes out, it's better. But let's see what we got. Do the long travel and see how it does. I think I'm gonna drag through the hole there. Let me move over a little. Should miss the hole there. Sensitive little devils, especially on that long arm. Remember, this is 1/1000 over here to the 1. It pulls the indicator. flexing that arm. Say that's pretty good. Let's go back the other way. It should go over 0 when I try to feed in. So that checks this front edge of the table there within the first 8+ inches or so. We're within a few tenths, looks like. So I'm gonna run the spindle out and then we'll feed all the way out and check it. Vibration in the spindle there from the motor. It's probably shaking just a bit because I got to run it neutral like this for it to not be turning the spindle, and the oil's real cold and I think it's whipping and trying to pull the spindle some anyway. But that's in the millionth range, I guess. That's moving, you know, less than a tenth. With this spindle stuck out over a foot, about 1.5 feet probably. So let's kick this thing feet out. I may have to re-zero. I don't know how much it's going to drag that arm, but I'm just going to leave it right there. Probably closer to 4/10 because that whipped when I disengaged it. Let's zero it out. And we'll push it in and we'll see how it is at the other end. supposed to be a thou and a half. So, I don't know, maybe a thou. It's probably messed up now. I've fed it off the end. Let's do it one more time. Dirt. Maybe 7/10 at most, over 2 foot, still less than a thou, and it all trends one way, so that indicates that it could be some that this plate's not parallel and may not be sitting down on here square. It could be a little high spot out here raising that up, but overall looks like that it's really true, so I'm really happy about that. My Cincinnati would probably move 3 thou in that same distance. Let's run it crossways and see what we get. About a half a thou here. Re-zero and come back the other way. Stiff today, wants to keep kicking out. Actually looks better that way. It may have been dragging the rotation of the spindle some. Still within less than a half a thou over that 18-inch distance. Check it on the other end. across on that end and see if we're still showing square. We're now checking on the other side of the table and with it in a different location. Hit my stop block. I'd say that's real good myself. My sheets on this machine are out of a handbook on the boring mills rather, and according to this, the top of the table flat, or should be flat and level crossways within 1,036 inches. I don't have a 36 inch here to test, but we're within a half thou and 18, so hopefully that would extend out to 1 and 36, so we're within a new value there, which is excellent. Same thing lengthwise, has the same tolerance, 1,036, and we did 24, and it was between half thou and 7/10, depending on whether you measured it stopped or started, so a little difficult to tell. But nevertheless, I think we would hold that tolerance of 1,036. Because most of the wear is right up here by the head. Well, this is floor type machine, so we can skip all that. And next up is going to be checking the squareness of the column to the table. So I need to get this block turned up on its side and indicate up and down and see how much we've got to yank this thing which directions in order to get it where it needs to be. So let's check the cross face of this like we were milling this. I'm not sure that I have this block exactly square, so again we're looking for the trend that is continuous. Alright, let's try this again. Feeding across. Nice and square that way too. Looks like it's about 2/10 and 18 inches. That's against the stop blocks, so it could be angled a little bit to get it to run actually true across there, because it all trended one way. It didn't go up and didn't come back the other way, which means the axis is pretty true the way we want it.